Hi everyone, and welcome back. So today we're going to look at theoretical and experimental probability, and this is on page 477 in your textbook. All right, so go ahead and put your name up at the top, your class hour, and today's date. And let's go ahead and take a look. So today what we're going to learn is to find and compare experimental and theoretical probabilities. So exactly how it says. Find and compare experimental and theoretical probabilities. And then we're also going to predict the actions of a larger group. Predict the actions of a larger group. Predict the actions of a larger group. All right, so the whole thing we're going to be looking at for today is what should be happening versus what's actually happening. Okay, so let's make a little note out here. So should versus actual. All right, so what should be happening versus what's actually happening. All right, let's take a look at number one here. It says the table shows the results of an experiment in which a number cube was rolled. Find the experimental probability of rolling a 6 for this experiment. Then compare the experimental probability with the theoretical probability. All right. So first thing is to figure out. Let's see. Sorry, I just lost my train of thought. Find the experimental. Okay, so we got to find the experimental probability. So the experimental probability. So we're looking at the 6s right here. Okay, and this one they got 6 times. Okay, they rolled a 6 different times. So the ways that it did happen was 6 times. So the probability of rolling a 6 occurred 6 times, and then we remember it's the ways that it can happen over the total ways. So how many total ways did it actually end up rolling? So 4 plus 6 is 10. 10 plus 2 makes 12. 12 plus 8 makes 20. 20 plus 3 is 23. And then plus 6 makes 29. So they ended up rolling 29 times altogether. Okay? 29 times altogether. So 6 over 29. All right? Now we need to see if that can reduce. So will 6 over 29 reduce? And it will not. All right? So then what we need to do is we need to compare it to the experimental probability, so we've got 6/29 with the theoretical. So theoretically, how often should I roll a 6? All right, so theoretically, if I roll a 6, it's going to happen 1 in 6 times, right? Okay, because there's only 1 6 on there. So now we're going to, let's change these into decimals so we can kind of see what we have. So let's take 6 divided by 29. 6 divided by 29, and it's about 21%. Okay, and then let's find out what 1/6 is. So 1/6 is about 17%. Okay, so we're supposed to compare them. So in this case, the experimental probability was higher than the theoretical probability. The experimental probability was higher than the theoretical probability. And apparently someone set off their car alarm. Alrighty then. Okay, so we have the experimental probability was higher than the theoretical probability. So what you'll do is you'll find what happened in the experiment, okay, versus what should have actually happened. So it's should versus actual. Okay, so what actually happened was 21%, but only what should have happened was 17%. And then we're going to compare those. So you either say this one was higher than this one or this one was lower than this one. You can do it either way. Okay, go ahead and try the guided question by yourself. And let's take a look. So it says, find the experimental probability of rolling a 4 for the experiment above, then compare it to the theoretical. So experimental-wise, we roll a 4. Okay, a 4 occurred 8 times out of 29. Okay, that's not going to reduce. So let's go ahead and find the percent on that then. So that's 8 over 29, which is about 28%. And then a 4 over here would only be 1 out of 6 times, which is 17%. All right, so again, what we found was in the experiment, it happened more times than what it should have. All right, so it's the same answer as the last time. So let's see them right over here. So the experimental probability was higher than the theoretical probability. Okay? And it's kind of weird because it seems like for the most part, experimental-wise, it always tends to be higher than what theoretically should happen. Okay, now not always, but it just seems like it does come out that way. So it's like, well, if in theory it should happen this way, then how come it always comes out this way? It's just that it is how it is. Okay? All right, let's look at number 2, and this is actually the last one. All right, this time we have a new survey. It says the table shows the results of a survey that asked 200 teens what they would be doing if they were not online. Out of a similar group of 450 teens, predict how many would listen to music. All right, so first let's figure out how many people were actually involved here. So we have 50 plus 52 plus 54 plus 18 plus 10 plus 16. Oh, it's 200. Well, shoot, they already told me. Duh. Okay. I guess it helped if I read the directions. Okay, never mind. They added up for us. It was 200. All right, so so for this one, we have to figure out what they would be doing if they're not online, and then how many would actually be listening to music. So 52 out of 200 said that they would be listening to music. 52 out of 200 said that they would be listening to music. Okay, so let's figure out what percent that is. So, the probability of music. Okay, it's 52 out of 200. So let's find the percent. So about what percent is that? So 52 out of 200, that's about 26%. So approximately 26% will say that they're going to do that. Now we're going to find the population to be 450. So we need 26% of, which means times, and 450. Okay, so 26% times 450. Okay, 26%. We're going to use second and left parenthesis for the percent sign, and then times 200. 26% times, 450. I think I said 200. 450. And we should get 117. All right, and that's it. So 117. Okay, so you'll find the probability of what the experiment said, then you're going to multiply by the new population. Okay? All right, and then let's try the got a question by ourselves. Okay. So out of 450 teens surveyed, how many would you expect to say they would be writing or drawing? So let's see, we got writing or drawing. There's 10. So that'll be 10 out of 200. Oops, I forgot. I'll just put W/D. Okay, so 10 out of 200. And let's go ahead and find the percent of that. So what is 10 out of 200? That would be 5%. Okay, and then out of 450, so we're going to do 5% of 450. And that's 22.5. Okay, so we'll just leave it like that. Well, let's say 22 or 23. 22 or 23, because you can't have a half a person. Okay. All right, so that's it for this lesson. Thanks for watching. Give me a thumbs up and subscribe if you haven't already, and I'll see you next time. Thanks, bye.